And welcome back to new video on refrigerant that is only available on your favorite channel AVM Tech Android. This is a QR code of my channel, and again, as you know, the channel name is AVM Tech Android. So by scanning this QR code or just writing this AVM Tech Android on the YouTube, you can refer this free video on refrigerant. So in the present video, we are going to discuss about different type of refrigerant, what is refrigerant, how we can use that refrigerant, what are the different property of the refrigerant, and at the end we are going to discuss about these different generations related to refrigerant. So without wasting much time, let us continue with the video based on refrigerant. So what is refrigerant first? So refrigerant is a working substance which is acting as a medium by which heat is transferring in the refrigeration system. And the refrigerant is a working substance which undergoes a phase change in the VCR cycle. So what happens here is mentioned. Refrigerant absorbs the latent heat at low temperature in the evaporator and gets converted into liquid to vapor, thus producing cooling effect. So what happens in the ice box that is mentioned here? Liquid to vapor conversion will be observed, that is phase change is observed, and because of that refrigerant effect is observed. Refrigerant reject the latent heat at atmospheric or at higher temperature from the condenser, and its phase will change from vapor to liquid. So this line is talking about the process that is observed in the condenser of simple VCR cycle. So if we are talking about, you can say, evaporator, or if we are talking about the condenser, in both the case heat exchange is observed, and when the heat exchange is observed, here the phase change is also observed, liquid to vapor, or you can say vapor to liquid. Again, as you know, we had discussed the refrigerant in the simple VCR cycle or in the domestic refrigerator. Condenser and evaporator are heat exchanger, and in the 5th semester in the heat transfer subject you learn about heat exchanger in detail. The links are also available in the description box if you want to go in detail about heat exchanger. Except air, all the refrigerant change their phase during the operation. So other than air, all the refrigerants are going for phase change in the simple VCR cycle. Air is only an exception. Now we have to go for classification of the refrigerant. So if we'll go for classification of refrigerant, there are different ways to classify the refrigerant. One by one we are going to. First way to classify the refrigerant, that is according to the primary and secondary refrigerant. So we are going to discuss in detail about both the refrigerant. So what is primary refrigerant? So primary refrigerant are those which directly comes in contact with the cooling load application and absorb heat from it. That is SO2, CO2, NH3, freon group, that is carbon dioxide, ammonia, freon group, and sulfur dioxide. So these are primary refrigerant which are directly come in contact with the cooling load application. But if we talk about the secondary refrigerant, they are those which act as a medium between the refrigeration cycle and cooling load application. So these are not directly come in contact with the cooling load application like primary refrigerant. The example which you can see here, are NaCl, CaCl2, etc. are secondary refrigerant. So there are some application where we have to go for secondary refrigerant. So we will discuss in detail about secondary refrigerant at later stage. Second way to classify the refrigerant, that is according to the chemical composition. So either it is a hydrogen compound, it is a azeotrope. So in case of hydrogen compound, hydrocarbon compound, what happens? These are refrigerant formed from the base of methane or ethane, that is CH4 or C2H6. The hydrogen of the methane or ethane, that is replaced by chlorine, fluorine, or by both. So if we talk about CCl2F2, that is dichloro-difluoromethane, or if we talk about CHCl2F, that is monofluoro-dichloromethane, in both the case what you will observe, this hydrogen either of CH4 or of C2H6, that will be either replaced by chlorine, fluorine, or it is replaced by both, that is hydrocarbon compound. Now second is azeotrope. So what happens in azeotrope is they are mixture of refrigerant. Important is it is a mixture of refrigerant and they have some specific properties. The mixture does not get separated even with the application of pressure and temperature. Means once the mixture is prepared and that will act as a working substance, whether there is a change in the pressure and temperature, separation is not possible. After azeotrope, you can see next is zeotropes. So these are chemical blend of HCFC, HFC and HFCs. So what is that? It is mentioned here. HCFC, it means molecule contain hydrogen, chlorine, fluorine and carbon. Okay, hydrogen, chlorine, fluorine, carbon. HFC means the molecule contain hydrogen, fluorine and carbon. And if I am talking about HFCs, that is this third one, it means the molecule also contains sulfur. This is sulfur along with HFC. So HFC, that stands for hydrogen, fluorine, carbon, and now sulfur is added. So these zeotropes are chemical blend of HCFC, HFC or HFCs, or you can say it is HCFC, HFC and SC only, that is hydrogen and carbon. The temperature of zeotrope does not remain constant during the boiling or condensation. So here if we go for zeotropes, the temperature does not remain constant. Next is hydrocarbons or organic compound. Sometimes the hydrocarbon like CH4, that is methane, ethane, propane, butane, are used as a refrigerant and they are also called organic compound. So if we use hydrogen, if we go for methane, ethane, propane, butane, in that case they are known as a hydrocarbon or organic compound. If we will go for inorganic compound, what we will observe, instead of going with this CH4, C2H6, what we are doing, we are going with the conventional refrigerant that include air, water, carbon dioxide, ammonia, sulfur oxide are inorganic compound. Okay, so if we go for air, water, carbon dioxide, sulfur oxide, ammonia, in that case they are known as inorganic compound. And in addition to above this, some refrigerants are also available with the nitrogen compound and unsaturated organic compound having base of ethylene or propylene. So this is one of the way to classify the refrigerant. So either it is a hydrocarbon or it is an organic compound or it is an inorganic compound or it is a azeotrope or it is a zeotrope. Now the next way to classify the refrigerant, that is according to the safety. So it is a very important group 1. They are safest refrigerant. That include R11, R12, R22, R113, R502. So these R11, R12, R22, R113, R502, these are safest refrigerant. Group 2, they are toxic and somewhat inflammable, that R717, R611, R40, etc. Group 3, very dangerous, you can see they are highly inflammable, R1150, R1270, R600, R170. Here this R, that stand for refrigerant and this is number. So how to convert this number into chemical formula, or how to convert the chemical formula into this number, in the next few slides we are going to discuss. When the hydrogen is included, it includes the flammability of the refrigerant, and when the chlorine increase, the toxicity will increase. So when we are talking about this refrigerant which are toxic and you can say they are flammable, in that case hydrogen is available as well as chlorine is also available. So group 1 is the safest, group 3 is highly inflammable. Next way to classify the refrigerant, that is according to the application. So where we are using the refrigerant, one, you can see we can use it in the domestic refrigerator, we are using in vapor absorption system, that include you can say NH3H2O, H2O LIBR, that is ammonia water absorption system, water lithium bromide system, etc. We can use the refrigerant in the cryogenic application, which create a very low temperature in the range of 113 Kelvin to 0 Kelvin. So the oxygen, hydrogen, helium, nitrogen or air of them in the liquid form are used as a cryogenic refrigerant. So whenever we want to go for very low temperature application, we have to go for cryogenic refrigerant. Next is the brine. You can see these are the secondary refrigerant used in some system which include NaCl or CaCl2. Again I am telling that we will discuss in detail about secondary refrigerant in the same video lecture. Next is antifreezant. So these are mixed with water to prevent freezing of water. So it can be used for low temperature application, that is we can use the glycerin, glycol or methyl alcohol. So this will be added into the water. So water temperature that will drop and we can go for low temperature application along with the water as a refrigerant, that is antifreezant. Now we'll go for designation of refrigerant, like if it is mentioned R11 or R22 or R33, how we'll get the chemical name of that refrigerant. So here you can see the chemical name of refrigerant are long like we had discussed dichloro, difluoromethane, or that's all. So if we do not want to remember the chemical name, we are simply telling that it is R11. But if R11 is given to us and if you want to know what is the chemical formula of R11, we are going to discuss about that part. As the chemical name of refrigerants are too long, ASHARE, that is American Society for Heating, Refrigeration and Air Conditioning Engineering, has given the refrigerant a small number from which their chemical composition can be identified. So now we will start with that part, that is for saturated hydrocarbon, let the general composition of refrigerant is Ca, Hb, Fc and Cld. So A is the number of carbon, B is the number of hydrogen, C is the number of fluorine and D is the number of chlorine. So carbon, hydrogen, fluorine and chlorine. With A, B, C, D, Now for the saturated hydrocarbon, generally we know that B plus C plus D, that is equals to 2A plus 2, and the refrigerant is designated with R, that is your refrigerant, with A minus 1 into B plus 1 into C. This is your refrigerant. The right hand side number will be indicated the number of fluorine atom. Second number from RHS minus 1 represent number of hydrogen atom, and LHS number plus 1 that represent the carbon atom. Okay, so these two things you have to remember. Refrigerant that will be designated as R stand for refrigerant, into A minus 1, B plus 1 and C. And for saturated hydrocarbon, B plus C plus D, that is equals to 2A plus 2. So what is A, what is B, what is C and what is D, that is known to us. Now if you want to know what is the chemical name of R11, let us find it out. So R11 means we can write R011. Now A minus 1, that is equals to 0. This A minus 1, that is equals to 0. So A equals to 1 means number of carbon atom is 1. Now next B plus 1. So B plus 1 equals to 1 means B is 0. So hydrogen atom is 0. Third is this one. So this C, that is equals to 1. So fluorine atom is 1. Okay. So A is 1, B is 0, C is 1. So now what we have to do? We have to go for B plus D plus C, that is equals to 2A plus 2. So what is the B value? B value is 0. D value is not known to us. C value is 1, equal to 2 into 1 plus 2. So D equals to 3. That is equals to number of chlorine atom. So the chemical name of the R11 is CCl3F, that is trichloro monofluoromethane. I hope it is very much clear to you. We had find out what is the chemical name of R11. So when we go with this exercise step by step, we can find out the R11 is CCl3F, that is trichloro monofluoromethane. In the same way, you can find out what is the chemical name of R12 and so on. This is the procedure. This is the procedure how to find out chemical name of any refrigerant, that is either R11, R12 or any else. I hope friend it is very much clear to you. Now you can see one more way. Find out the refrigerant number of trifluoroethane. Trifluoroethane, that is C2Cl3F3. Means I can write C2H0F3Cl3. So A equals to 2, B equals to 0, C equals to 3 and D equals to also 3. 2, 0, 3, 3. So I can write R into A minus 1, B plus 1 into C, that is R into 2 minus 1, 0 plus 1 and 3, that is R113. So if R113 is given, the chemical name is this trifluoroethane, or if the chemical name is given and you have to find out refrigerant number, that is R113. So this is a very important thing. The question may be there in your technical test, in your campus interview, in the competitive exam, in your internal test, as a MCQ also. Find out the refrigerant number, or you can say it is given that find out the chemical formula of this refrigerant number. So friend, I hope it is very much clear to you. Now let us discuss about the property of the refrigerant. So we will go for different property. First is the thermodynamic property. So property means what we are expecting from the refrigerant. So what we are expecting in the thermodynamic property, that include low freezing point, low boiling point, high latent heat of vaporization, high saturation temperature, pressure in the evaporator and condenser should be positive, that is above atmosphere, to avoid the chance of leakage of air into the system. But pressure should not be too high or too low. It should be slightly greater than the atmospheric pressure. So what we can expect is low freezing point, low boiling point, high latent heat of vaporization, high saturation temperature and positive pressure in the thermodynamic property. In the physical property, low specific volume of vapor, low viscosity, high thermal conductivity, high electric resistance, leakage of the refrigerant should be detected easily. This is a very important thing. Leakage should be detected easily. Chemical property, that include it should be chemically stable, decomposition is not allowed, it should be non-toxic, non-corrosive, and it should be non-flammable and non-explosive. Also, we are expecting high coefficient of performance, and that is easily available at low cost. That is a very important what we are expecting. So these are, you can say, thermodynamic, physical, chemical and other required property of the refrigerant. So now some of the properties include low freezing point. So this low freezing point, it should be as low as possible. So we will get a very low temperature in the evaporator. So best refrigerant effect can be achieved. Low boiling temperature at atmospheric pressure is required. Otherwise what happens? Compressor has to handle the large volume of suction air. Low condenser temperature is desirable, otherwise the system has to make leak proof against the high pressure in the condenser, which will increase the cost and weight of the system. High latent heat of vaporization is required, so large amount of heat can be absorbed with the given mass of the refrigerant, or you can say the mass of refrigerant can be reduced for a given cooling load. And the last is, you can say, the critical temperature should be higher so that the condensation of the refrigerant can be made even at a higher temperature. So these are some important properties for the refrigerant. Now we'll go for secondary refrigerant. So till this time we had discussed about a primary refrigerant, in which refrigerant is come in direct contact with the cooling load application. Now we will discuss why we have to go for secondary refrigerant, what are the different types of secondary refrigerant and where they are applicable. So this is also a very important question for your exam point of view, for your knowledge point of view. In some application, it is not recommended to use refrigerant directly for cooling purpose. In some air conditioning application, refrigerants are not directly exposed for the safety consideration. So some application where safety is important, the refrigerant should not be come directly in the contact with the system. Also, in higher capacity system like air conditioning system, or you can say cold storage, it is very difficult to circulate the refrigerant, because if the size is very big, the mass of refrigerant which is required to be circulate in the system is very high, and then this problem will come. It is difficult to circulate the refrigerant. So in some cases it is necessary to use the secondary refrigerant, but the amount of refrigerant effect produced will be reduced. So if we go for secondary refrigerant, the refrigerant effect will be reduced. But there are some cases where we have to go for secondary refrigerant for safety consideration. So some advantage to use the secondary refrigerant are easy to circulate and control. It keeps the load space safe from the toxic refrigerant, and the size of pipelines required, they are lower. The power consumption is also less. So these are some advantage of secondary refrigerant, which include safety, you can say easy control on circulation, as well as the power consumption is less, as well as the size of pipeline required are smaller. So what are the secondary refrigerant? So secondary refrigerant include water, brine. So if we talk about water, we know that we cannot go below 0 degrees Celsius. And what is brine? We had discussed, it is the solution produced by dissolving different salt in the water. As the salt is dissolved in the water, it absorbs the latent heat of solution, and thus the freezing point of the solution, that is brine, that will be lower than the water, and we can go for low temperature application. So the concentration of salt in the water is very important, because as the concentration increases, the freezing temperature will decrease up to some point, thereafter it increases. So this is a very important. Freezing point temperature will drop when we add different salt into the water. So the mostly used brine include NaCl, as well as you can say it include CaCl too. So here again the comparison is given between NaCl, that is sodium chloride, and calcium chloride, that is CaCl2. So this NaCl can produce the temperature up to -15, whereas this CaCl2 can produce up to -50. NaCl is a very cheaper. Both brines are non-flammable and possess a required refrigerant properties, but the brines are very corrosive in nature. Generally, steel with some coating of lead oxide is used as a material. So here corrosion is a problem, otherwise we can achieve a very low temperature easily. Also, some inhibitors are added into the brine to reduce the corrosion effect. So we add the inhibitors, so again the corrosion effect will be minimized. In addition to above, the periodic inspection of the material is required. So periodically we have to check all the refrigerant carrying pipelines. CaCl2, that is calcium chloride, calcium chloride brine is most popular secondary refrigerant used in the industry. So CaCl2 is widely used in the industry as it produces very low temperature, you can say -50. Third is, you can see, glycol. So in some cases antifreeze, that is liquid chemical, is added to the water and that solution is prepared. They are called glycols. They are less corrosive compared to the brines, and they possess a very good refrigerant properties. They are not react with the steel, aluminum or copper. So mainly two type of glycols are used, that include ethylene glycol or propylene glycol. So again you observe the comparison. Ethylene glycol are a little more toxic compared to the propylene glycol. So they are not used in direct contact with the food, very important. And this glycol can produce the temperature up to -50. So this can produce the temperature up to -50, but they are somewhat toxic. So they cannot come in direct contact with the food, otherwise it will create a poison. So these glycols are, you can say, give a benefit over corrosion, but the disadvantage is they are somewhat toxic. Now friend, we had discussed about primary refrigerant, we had discussed about secondary refrigerant, and now we have to discuss about the new refrigerant. So the question that will come in your mind is why we have to go for why we have to go for new refrigerant. Once we had discussed primary refrigerant, secondary refrigerant, and now we are going to discuss about new refrigerant. So you are very much aware about greenhouse gases. Also you are very much aware about ozone layer depletion. So the same thing is mentioned here, because when we are going with HFC or CFC, it contains chlorofluorocarbon, and these gases allow the sunlight to pass through them but does not allow low temperature radiation from the earth to escape from the atmosphere, and that is creating a greenhouse effect. It will cause global warming and also create some harmful effect like extreme drought, rainfall, or changing weather pattern. We are very much aware about this change in the weather pattern. The effect of refrigerant on the global warming is measured by global warming potential GWP, and GWP is defined as relatively ability of refrigerant gas to trap the heat to the amount of gas present in the atmosphere. So what happens here is this chlorofluorocarbon is again a very harmful to ozone layer, and due to leakage of this CFC from the refrigeration and air conditioning system, this gas will react with the ozone layer and it create depletion of the ozone, thus creating a hole in the ozone layer. This is a very important, the creating hole in the ozone layer. This characteristic of the refrigerant is measured by ozone depletion potential. If there is a hole in the ozone layer, harmful rays from the sun that will enter on the earth, and it is creating a very dangerous effect on the human skin. So CFC is, so you can see this CFC is extremely stable, so it can reach to the ozone layer and cause its depletion due to separation of chlorine from it. But instead of CFC, if we'll go for HCFC, in that case again the chlorine atom is available, but it is not stable due to presence of hydrogen. Thus it break before it reach to the ozone layer, and hence it is not harmful for the ozone layer. But instead of HCFC, if we go for HFC, it does not contain chlorine atom at all, and hence there is no chance of ozone layer depletion. So we have to replace the existing refrigerant by new refrigerant for two reasons. One is ozone layer safety, and second is prevent the global warming. So what we are doing is R12 that will be replaced by R134A, R11 that will be replaced by R134A or R123, R22 that will be replaced by R407C or R502, or you can say R402 and R403A. But this ammonia and water are very good option for this CFC. These two are the best, that is ammonia, NH3 and water, to replace CFC. Now if we talk about the future industrial refrigerant, we had discussed that the water with some CaCl2 or NaCl2, that is creating a very low temperature. So that is you can say refrigerant that will be used in the industry. Other than that, all, instead of using all this new refrigerant, ammonia is having pump size lower and the power requirement for the pump is lower compared to all other refrigerant, and hence the suction line for ammonia will be smaller, plus the heat transfer coefficient of ammonia is very high due to higher thermal conductivity and specific heat. The coefficient of performance of all the refrigerant systems are almost same, but in case of ammonia, you can see heat transfer coefficient is high, pump size is smaller, power requirement is less, the pipeline's diameters are smaller, and hence generally ammonia is the best option for future refrigerant. But the major disadvantage to use the ammonia is it is a very toxic and it requires special care for the safety point of view, and generally the ammonia has tendency to leak from the joint. So generally it is not favorable to use NH3 refrigerant near to the school, near to the hospital and other occupied spaces. So if your plant is located near the school, hospital or other occupied spaces, it is not desirable to use ammonia as a refrigerant. This is a graph taken from a research paper which include first, second, third and fourth generation of refrigerant starting from 1830 to still we are doing research in this field. So initially you can see we are using ether, carbon dioxide, ammonia, sulfur oxide as a refrigerant. Slowly in the second generation we will move towards SC, NH3 and H2O. Then we are moving from second to third generation that include CHC, FCSC, ammonia and water. From that we are going with the new refrigerant, that is we are going with HFC, HCFC, CO2, NH3, or you can say we'll go with this again NH3 and water, and from that we are moving with the latest fourth generation that is include hydrocarbon HFC, HFO, CO2, NH3, H2O, and still the research is going in the field of new refrigerant for the system which give best COP and also minimize the greenhouse gas effect and not damaging the ozone layer. Some of the important questions are mentioned here. You can go through these questions, and in this video we had discussed everything about refrigerant, what is refrigerant, what is refrigerant effect, what are the classification of the refrigerant, what are the properties of the refrigerant, what is the primary refrigerant, what is the secondary refrigerant, what are that applications, how to designate the chemical name of refrigerant into number or number into the name. Also, what are the advantage and disadvantage of different refrigerant that we had discussed. And friend, this is end of this video related to refrigerant. If you like this video, then do not forget to subscribe this channel. Do not forget to press like button for this video, and very important, do not forget to share this channel among your friends, among your relative, among all the needy persons which need this kind of help at free of cost. Thank you.